Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the solutions of JEE Advanced 2025 paper 2. And this is the section 1 in which only single correct choice questions are there, and there are 4 questions which constitutes the total 12 marks. So in this first question, you can see this is a question of dimensional analysis, and I would rate this question in category of easy question. So you can see that there is a formula Z is equal to S square sigma by K, where S is the EMF generated per unit temperature, sigma is the electrical conductivity, and K is the thermal conductivity. So we have to find out the dimensional formula of Z. So we can say that Z is equal to S square sigma by K. Now obviously S is the EMF generated per unit temperature, so we can write it down as V by T. V is obviously voltage, and sigma is the electrical conductivity. So we know that resistance R is equal to L by sigma A, and R is also equal to V by I. So sigma is equal to I L by V A, and dimensionally area is L square. So I am writing it down dimensionally only. So it would be I by V L. I have cancelled the dimensions of area with length, so there is single length in the denominator. Okay, we are not concerned with the actual formula. Actually, we are concerned only with the dimensions. So I'm just writing it down in the perspective of dimensions. And we know that the power, which means that rate of heat flow through thermal heat flow, obviously, is delta T into Ka divided by length. And K is dimensionally, this is power into L by delta T is obviously dimensionally temperature, so T into A. And I am cancelling again the dimensions of area, which is L square, with L. So K is P by TL. Now I am writing this down in the formula, and S square will be V square by T square, sigma will be I by VL, and K in the denominator will be P, and this is TL. So cancelling V with V, T with T, L with L. So this is V into I, and this is power into temperature. Now V into I is also power, and this is also power. So this is cancelled, and the dimensions of this quantity Z will be equal to K inverse. Okay, so the correct answer will be B. Now we move on the next question. In this question, you can see that there are two coaxial cylinders, and the radius of the inner cylinder is root 2r, and radius of the outer cylinder is 2r. The length of these two cylinders is L, and the inner part of the inner cylinder is hollow, as well as some dielectric medium is filled between these two cylinders. Now the outer cylinder is also grounded, and the dielectric constant is 5. Now obviously some charge is given to the inner cylinder, Q, and the bounded charge will be on the inner surface of the outer cylinder, which is minus Q, and the charge on the outermost surface of the cylinder will be 0, as it is grounded. Now this is a plane which is imaginary plane which is passing through this system, and this distance is r. So we have to find out the total flux linked with this plane. So let us draw this diagram again on the next page. So you can see that this is the first outer cylinder, and this is the inner cylinder. Okay, and this will be the plane. I am drawing the plane. This will be the plane which is passing through these two, like that, and this is the center. Okay, this distance is r, and obviously this and this angle, see, this is r, this is root 2r, and this is 2r. Therefore this angle will be 45, and this complete angle, this angle will be 60, you can see. And now we can see that the electric field will be only between these two regions. The electric field inside will be 0 and electric field outside will be 0, and E in this region will be equal to 2k lambda by r, and epsilon r also will come because the medium in this space is having a dielectric constant of 5. So E is lambda by 10 pi epsilon naught r. Okay, because epsilon r is 5 and k is 1 upon 4 pi epsilon naught. Now let us see that the electric field at this point, let's suppose it is E, and let us draw the two lines connecting these points like this, and this angle is theta and this angle is d theta. This angle will be theta, and the component of electric field which would contribute in the flux will be E cos theta. So d phi, which is the flux, will be E cos theta into this area. This area will be this length into depth. Now let us see that if this is y, so this small length will be dy and area will be dy into L, and y, you can see that tan theta, this tan theta will be y upon this r, and this is small r. This is small r, this is capital R, this is y. So tan theta is y upon r, capital R. So y is equal to r tan theta. So dy is r sec square theta d theta. Okay, this is dy. And d phi, flux, will be E will be lambda upon 10 pi epsilon naught r into cos theta into dy, which is r sec square theta d theta into L. Okay, and we know that cos theta will be equal to this capital R upon a small r. So R will be equal to r sec theta. So total flux will be integration of 2, because this region as well as this region will contribute in flux. So there will be 2 and 2 will be cancelled with 10. So it will be, and lambda is q by L. So q by 5 pi epsilon naught L, and this is L, and here will be r sec theta d theta, and in the denominator small r will be r sec theta. Cancelling r sec theta with r sec theta, L with L. Phi will be equal to q by 5 pi epsilon naught integration of d theta. Now the limit of d theta will be from this angle is 45 and this angle is 60. So it would be from pi by 4 to pi by 3. So phi will be finally equal to q by 5 pi epsilon naught pi by 3 minus pi by 4. So phi will be equal to q by 60 pi epsilon naught, and pi will be cancelled out. So Q by 60 epsilon naught. So the correct answer will be option number C. Now we move on the next question. In this question, you can see that there is a single rod of mass m and length L, which is hinged from this end O, and it is connected to two similar springs of same spring constant K in two different ways. In the first way, both the springs are connected to different points with the rod. One is connected at the end of the rod and other one is connected to the center of the rod. And in the second case, both are connected to the center of the rod in this type. Now we are displacing the rod, we are displacing this end of the rod with respect to this end because O point is hinged, so it could not move. So we are just displacing this end, so it would perform SHM like that, small SHM. And this end is also performing SHM like that. Now the frequency of SHM, small SHM in the first case is F1 and the frequency of a small SHM in the second case is F2. So we have to find out F1 upon F2. So I've already drawn the diagram on this page. So you can see that when we will displace this rod by a small angle theta, this is theta. So this x1, for small angles, this arc length will be equal to L by 2 theta, in fact L theta, and this x2 will be equal to L by 2 theta. Now obviously this spring will be stretched, so it would be pulling the rod, and this would be compressed and hence it would be pushing the rod. Now F1 will be equal to K into x1, which is L theta, and F2 will be equal to K into x2, which is L by 2 theta. Okay, and the torque of both the forces, see, these two forces are producing a torque about O, which is in the same sense. So torque will be the F1 into L, this is L, and plus F2 into L by 2. So torque will be equal to K L square theta plus K L square theta by 4. So torque will be equal to 5 by 4 K L square theta, and this torque will be equal to I alpha, where I is moment of inertia of the rod about this hinge point. So it would be 5 by 4 K L square theta, and that is equal to I, which is M L square by 3 and alpha. So cancelling this, and alpha is obviously omega square theta in SHM. So cancelling theta with theta, L square with L square, omega 1 square will be equal to under root of 15 by 4 K by M, and this is omega 1, and we can also write it down as 2 pi F1. Okay, and in this case, in the second case, as you can see that both the springs are connected to the same point. So if we will displace this rod like that, then this is x. So x will be equal to, this angle is theta, so x will be equal to L by 2 theta, and this spring will be compressed and this will be elongated. So both springs will push in this direction with the equal force. So 2F will be the total force, where F will be equal to K into theta. Theta is L by 2, in fact K into x. X will be L by 2 theta. So the torque will be equal to 2F into L by 2. So torque will be F into L. So torque will be equal to K L square theta by 2, and this torque is I alpha. I is ml square by 3, alpha is omega 2 square theta. Cancelling theta with theta, L square with L square, omega 2 will be equal to under root of 3 by 2, and this is K by M, and this is 2 pi F2. Okay, so F1 by F2 will be equal to under root of 15 by 4, and this will be 3 by 2. So it would be equal to under root of 5 by 2. So the correct answer will be C. Now we move on the next question. In this question, you can see that there is a star of mass m2, and there is another star of mass m1, and m1 is very greater than m2, and m2 is revolving around the m1 star in orbit of radius r. So now what happens that m1 star is slowly acquiring the mass from m2. So mass is being transferred from m2 to m1 at a constant rate of gamma. So in this transfer process, there is no loss of mass, and we have to find out the relative change of separation rate of the radius between these two. So we know that in this case m2 r omega square will be acting in the backward direction, and F will be acting in the forward direction. F is the force. So we can say that F will be equal to m2 r omega square, and F is g m1 m2 by r square, and that would be equal to m2 r omega square, cancelling m2 with m2. So g m1 by r square will be equal to r omega square. Now we also know that angular momentum in this process will be constant. So angular momentum L will be equal to I omega. I is m2 r square into omega, and therefore omega will be equal to L upon m2 r square. So substituting this value of omega, gm1 by r square is equal to r. In fact, we can write it down as r cube is equal to omega square, which is L square upon m2 square r ki power 4. Okay, so cancelling this with this. So you can see that g m1 m2 square is equal to L square by r. Now if we differentiate this equation with respect to time, so this would be g, and this is m1 into 2m2 dm2 by dt plus m2 square into dm1 by dt, and that is equal to minus L square by r square into dr by dt. Okay, so let us again write it down here. G into 2m1 m2 into dm2 by dt plus m2 square into dm1 by dt, m2 square into dm1 by dt, and that is equal to minus L square by r square into dr by dt. Okay, so we know that mass is being transferred from m2 to m1 at a rate of gamma. So the rate of change of mass of m2 will be minus gamma because it is decreasing, and the rate of change of mass of m1 will be plus gamma because it is increasing. Okay, and therefore we can substitute the values. So it is g, this is 2 m1 m2, and dm2 by dt is minus gamma, and plus m2 square and dm1 by dt is plus gamma, and this is let's suppose dr by dt, the quantity which we have to find out is z. Dr by r dt is z. So this is minus L square z by r. Now we know that L square is equal to g m1 m2 square into r. So let us substitute this value, g into 2 m1 m2 into minus gamma plus m2 square into gamma, and this is equal to minus z by r into L square is g m1 m2 square into r, g m1 m2 square into r, cancelling r with r, g with g. So z will be equal to, you can see that z will be equal to plus 2 by m2 gamma and uh, minus gamma by m1, and we know that m1 is very greater than m2, so 1 upon m1 will be very less than 1 upon m2. So z will be, neglecting this term, z will be equal to 2 gamma by m2. So the correct answer should be this one, but there is a problem of negative sign, and I don't know that why this negative sign is coming. Let us discuss that how radius will change. So we can see that g m1 m2 square is L square by r. Let's suppose, obviously m1 is very greater than m2. So let's suppose a dm mass is shifted from m2 to m1 in dt time. So the mass of m1 will not change because m1 is very greater than m2. Therefore dm mass would not change its mass, but mass of m2 will decrease. Okay, I think you will agree on this thing. So you can see that this term is decreasing eventually, and therefore radius should increase. So I think dr by dt should be positive. So the correct answer would be B, although. Now let's move on the next question. In this question, you can see that there is a neutral conducting sphere of radius r, and there is a charge q whose value is this, is kept at a distance of 2r from the center of the sphere. First of all, we have to find out the potential of the sphere in this condition. So potential of the sphere will be only due to q, because sphere is neutral itself, and therefore the potential of the sphere due to q will be the potential due to q at this point which is center of the sphere. So potential due to q at the center of the sphere will be kq by 2r, and k is 9 into 10 raised to power 9, q is 10 raised to power minus 8, and 2, r is 0.1. So this value will be 450 volts. So A option is correct. Now when we will connect this sphere to the ground, then obviously its net potential should be 0. So a charge will flow from the ground to keep its potential 0. So we know that the sum of potential of the sphere due to q and q will be 0. So kq by r will be the potential of the sphere due to the charge flown from the ground, and it should cancel out this 450 volt. So it should create a negative of 450 volt potential, so that net potential would be 0. So q in this case will be minus of 5 into 10 raised to power minus 9 coulomb, which means that the charge flown from the ground to the sphere is negative, and charge flown from the sphere to the ground is positive. So B is correct, and after grounding, if grounding is removed, the charge on the sphere is this. So obviously after grounding is removed, the sphere will get isolated, and the net charge on the sphere will become constant, which was minus 5 into 10 raised to power minus 9. So C is also correct. And the final electrostatic potential is this. Now finally what we have done, we have removed the grounding, and we have separated this q further away from the sphere. Now obviously we know that the charge after removing the grounding on the sphere is this minus 5 into 10 raised to power minus 9 and the charge is further shifted away. This is 3r. Now we know that the potential of a sphere is minus 450 volt due to its own charge, and the potential due to this charge will be, let's suppose, V. So this is the net potential of the sphere. But you can see that when this charge was kept at a distance of 2r, it was creating a 450 volt potential. But when it is shifted away, then obviously it would create a potential which is less than 450 volt. So the net potential finally would be some negative potential, and D option says that it is 300 volts, so it would be incorrect. So the only correct answers are A, B and C. Now let's move on the next question. In this question, you can see that there are two identical mirrors. These are the two mirrors, and these are concave mirrors. The focal length of each mirror is f, and you can see that there is a glass slab of thickness t and refractive index n0, which is placed just in midway of these two mirrors. Now there is a source of light which is embedded in the middle of this glass slab, and it is emitting light in all directions. So we have to find out the distance between these two mirrors so that the final image is formed at this point S itself. So there could be two possibilities. You can see that in the first possibility we can see that this ray diagram would be like that this ray will go like that, and then it will bend away from the normal, and this ray will fall on the mirror perpendicularly, and hence it will be reflected back. So mirror is watching this source to be at this position S dash, and this is Y. So if we write down the value of Y, we can, and let's suppose this is X. So Y will be equal to this distance is T by 2. So Y will be equal to T by 2 n0. This is the formula which we have already studied, that apparent depth is equal to real depth upon mu relative. Okay, and if this mirror is tracing that light ray back to its path, then obviously this mirror would see the S dash at its center of curvature. So it would be 2f. So we can say that the value of 2f will be equal to x plus this y. Y is t by 2n0. So x will be equal to 2f minus t by 2n0. This is the value of x. And the distance between the mirrors d will be equal to 2x plus t. So d will be equal to 2x, which is 4f minus t by n0 plus t. So the correct option will be option A. Now in the second case, you can see that the ray diagram could be like this also, that the ray will go like this. It will bend away from the normal. Let us draw again. And this point S dash will be the focus of this mirror F. Hence it would send this ray like this, and then it will fall on this mirror, and then it will be reflected, and again it would be traced back to S, because these two mirrors are having same focal length and the distance between these two mirrors is equal. The distance of these two mirrors from this slab is equal. Okay, so if this is X, so you can say that X plus, in fact, X plus Y by, in fact, X plus T by 2n0 should be equal to F. So X would be equal to F minus T by 2n0. So the distance between the mirrors will be 2x plus T. So D will be equal to 2F minus T by N naught plus T. So the distance between the mirrors would be equal to option B. So the correct answers would be A and B. Now we move on to the next question. In this question, you can see that there are 6 infinitely large thin non-conducting sheets which are fixed as shown in the figure. There are two configurations in which these sheets are arranged, and sigma naught is their surface charge densities, which is charge per unit area. Now the separation between any two consecutive sheets is 1 micrometer, and the value of sigma naught is this. So we have to choose the correct options. See, first of all, let us see the region 4. Let us check the option A. So in option A, it is stated that in region 4 of configuration 1, the magnitude of electric field is 0. See, you can see that in this region 4, the magnitude of electric field can be calculated by the fact that let's suppose the electric field created by this in this region is E in this direction, and the electric field created by this sigma naught in this region is E in this direction. So they will cancel out, this will cancel, this 2 will cancel, and this 2 will also be cancelled in this region. So in this region net electric field will be 0. So A is the correct option. Now in region 3 of configuration 2, the magnitude of electric field is sigma naught. So now in region 3, sigma naught by epsilon naught. Now in region 3, let us say that the electric field created by this one is E naught, which is sigma naught by 2 epsilon naught. So this will cancel out with this one, this will cancel out with this one, and these two will add up. So it would be E by 2, E naught by 2 plus E naught by 2, which is E naught, and E naught is sigma by sigma naught by 2 epsilon naught. But option 2 says that it is sigma naught by epsilon naught, which is also incorrect. The potential difference between first and last sheet of the configuration 1 is 5 volt. See, to find out the potential difference in these configurations, you can easily check that when we will move in this region, in this section, you can see, then if you can first of all write down the electric fields of the region in these two. You can see that in this region, the electric field due to this will be cancelled with this, and electric field due to this will be cancelled with this, and these two will add up. So electric field in this region will be in this direction, and it would be 2 E naught. Okay, and in this region 2, in region 2, I'll again show you that in region 2 the electric field due to this will be cancelled with this. Okay, and this will be cancelled with this, and this will be cancelled with this. So electric field in this region will be 0. Now again in region 3, in region 3 the electric field due to this one will be cancelled with this one, this cancels with this cancels with this, and these two will add up. So electric field here will be like that, and it would be 2 E again. And in region 5, let us see the case that in region 5 you can see that electric field due to this will be cancelled with this, electric field due to this will be cancelled with this, and these two will add up. So it would be 2 E naught. Okay, so this is the net electric field in these regions. So if I will move from plate A to plate B, so delta V will be 2 E naught 2 E naught into D in this region, and in this region it would be plus 2 E naught into D, this is E naught, and in this region it would be again plus 2 E naught into D. So the potential difference will not be, now let us check the value. So it would be 6 E naught D. Okay, and 6 E naught is sigma naught by 2 epsilon naught D is 1 micrometer. So this is 3 and epsilon naught is 9 into 10 raised to power minus 6. This is 10 raised to power minus 6 divided by 2 into 9 into 10 raised to power minus 12. Cancelling this with this, this with this. So this 2 will be also cancelled out. Yes. So there will be the potential difference of 3 volts. So this is also incorrect. And in option 4, the potential difference between first and last sheet of the configuration 2 is 0. So again, by that method I'll check the electric fields in these regions. So in this region 1, you can see that electric field due to this and this will be cancelled, due to this and this will be cancelled, and these two will add up, and it would be E naught. Okay. Now in the region 2, in region 2, this region, the electric field due to this and this will be cancelled out, and this will add up with this, so it would be 2 E naught in this direction, and this will add up, so there will be E naught in this direction. So the net field will be E naught in the backward direction. So net field will be only E naught, like that. In region 4, let us check in region 4, that in region 4 the electric field due to this and this will be cancelled out. Electric field due to this and this will be 2 E naught in this direction, and electric field due to this and this will be E naught in this direction. So the net electric field in this region will be E naught in backward direction. And finally in region 5. So in region 5, you can see that the electric field due to this will be cancelled with this, field of this will be cancelled with this, and these two will add up, so E naught will be like that. So when we will write down the potential difference, then this is A, this is B again. So delta V will be equal to E naught into D in this region, and plus this is minus E naught. Let us assume that electric field potential is decreasing, so delta V is minus E naught into D in this region, and this is plus E naught into D, and again minus E naught into D, and plus E naught into D and minus E naught into D. So it will be cancelled with this, this will be cancelled with this. So potential difference will be non-zero, but it says that potential difference in configuration 2 will be 0. So D option is also incorrect. So the only correct option is option A. Now we move in the next question. In this question, you can see that there is a Carnot engine. Let us first of all draw a Carnot engine. So here is the Carnot engine, and this is source, and this is sink, and the temperature of source is 1000 kelvins, and the efficiency of this Carnot engine is 0.4, and 0.4 is equal to 1 minus T sink upon T source, which is 1000. So T sink will be 600. So the temperature of cold reservoir will be 600. This is one of the correct answer. Now work extracted from the Carnot engine. Now it is given that the heat extracted from the Carnot engine from the heat extracted from the hot reservoir. This is Q1 and this is Q2. So Q1 is given as 150 joule. So we also know that 0.4, or we can say that T sink by T source, which is equal to 0.6, is also equal to Q2 by Q1. Okay, and Q1 is 150, so Q2 will be equal to 0.6 into 150, and it would be Q2 will be equal to 6 into 15, which is 90. Okay, and this work done, it will be Q1 minus Q2. So it would be 150 minus 90. So it would be 60 joules. So A is also correct. Now the temperature of colder reservoir of the heat pump is this. Now this work extracted from this heat engine, Carnot engine, is being supplied to a reverse Carnot engine or heat pump whose coefficient of performance is 10. And whose source temperature is 300. Source means hot reservoir. So let us again draw this is a reverse Carnot engine. So the work received by this engine will be the work extracted from the Carnot engine, which is 60 joule, and this is Q1. This is higher temperature, which is also called as source, and this is sink. This is Q2, and we know that the beta is 1 upon 1 minus T sink by T source. So beta is 10 and it is 1 upon 1 minus T sink is unknown, and T source is, I guess, 300. Yes, so it is 300. Okay. So 1 minus T sink by 300 will be equal to 0.1. T sink by 300 is equal to 0.9, and therefore T sink is equal to 270. So the temperature of sink is 270. So C option is also correct. And the heat supplied to the hot reservoir in one cycle of the heat pump is 540. So we have to find out Q1. So we also know that T sink, or we also know that the formula, this T sink upon 300, which is 0.9, is also equal to Q2 by Q1. And Q2, and we know that Q2 plus W, which is equal to Q1. So Q2 is equal to Q1 minus W. Okay, so 0.9 is equal to Q1 minus W by Q1. So 0.9 is equal to 1 minus W by Q1. So W by Q1 is equal to 0.1, and W is 60. So Q1 is 600. So D option is incorrect. So the correct answers are A, B and C. Now we move on the next question. In this question, you can see that there is a conducting solid sphere of radius r and mass m. It has a charge of q, and this sphere is rotated about an axis passing through the center and through the diameter, obviously, with an angular velocity of omega. So we have to find out the ratio of magnetic dipole moment to the angular momentum about the same axis for this sphere. See, first of all, let us see the situation that this is a solid sphere, and as the fact that it is conducting sphere, therefore all the charge on the sphere will be on its outer surface. Therefore, Q by, therefore M by L will not be equal to Q by 2M for this sphere. Obviously, this is wrong because this was correct if this was a hollow sphere, or this charge was completely distributed in the volume, then this was correct. But in this case, the charge is distributed on the surface and the angular momentum will be of the solid sphere. So first of all, we have to find out the magnetic moment of this hollow sphere, and for that we will use this theorem for hollow sphere. So M will be equal to Q by 2M into I omega. I is 2 by 3 M R square omega. Cancelling 2 with 2, M with M. M will be equal to Q R square omega by 3. This is the magnetic moment of this hollow sphere. But obviously, when we will calculate M by L, then we will consider it as the solid sphere because it is actually a solid sphere. So L will be equal to I omega, and L will be equal to I is 2 by 5 M R square omega. Okay, M is small m. So the ratio of M by L will be equal to Q R square omega by 3 upon 2 M R square omega by 5. Cancelling this R square omega, it is 5 by 3 and Q by 2M. So alpha is equal to 5 by 3. So the value of alpha is 1.6. Now we move on the next question. In this question you can see that there is a hydrogen atom which is initially at rest in the ground state. It absorbs a photon of frequency nu1 and ejects an electron of kinetic energy 10 eV. So H nu1 plus the initial energy was minus 13.6 as this atom was in ground state, and that is equal to 10 eV because obviously the photon which is absorbed by this hydrogen atom has released the only electron of this atom, and therefore the final energy of the atom will become 0 and the energy of electron will be 10. So this photon has compensated the energy to the hydrogen atom to make its energy 0, and therefore H nu1 will be equal to 23.6 eV. And this electron is then combined with a positron, and positron is plus E, and this is electron, and they revolve around their common center of mass in circle, and the hydrogen model is valid for this atom also. This resultant positronium atom releases an electron of frequency nu2, and it is in ground state, and after releasing this photon of frequency nu2, it starts to move with a kinetic energy of 5 eV. There is no loss of energy in whole process, and we have to find out the difference of energy of these two photons. So we can say that the energy which is received by this positronium atom is 10, and the energy it is received is 10, and we know that in the ground state E will be equal to mu by m into minus 13.6 into z square by n square, where mu is reduced mass. So we know this formula, and mu for this atom will be m into m upon 2m. So mu will be equal to m by 2. So energy in the ground state is equal to minus 13.6 by 2, and z is 1. This is 2. So z is 1 and n is also 1. Small n orbit is also 1. So this is minus 6.8. So the energy received by this atom is 10, and as a result of which this becomes uh, a atom of energy minus 6.8, plus it releases a photon of h nu 2, plus the atom has a kinetic energy of 5. So h nu 2 will be equal to 11.8, and the difference of these energies h nu 2 and h nu 1 is equal to 23.6 minus 11.8, which is also 11.8. So the correct answer is 11.8 eV. Now we move on the next question. In this question, you can see that there is a ideal monoatomic gas of n moles, and it is taken through a cycle WXYZW, WXYZW, and this cycle contains two consecutive adiabatic and isobaric processes, and this is the VT graph represented in the question. The volume of the gas at X, Y, in fact at W, X and Y are 64, 125 and 250. So at W it is 64 and at X it is 125 and at Y it is 250 cc, and the absolute temperature at TW is this, and nRTW is 1 joule. So we have to find out the heat absorbed by the gas in path XY. So let us see that obviously path XY is a isobaric process, and in isobaric process heat absorbed is NCP delta T. So N is N and Cp is 5 by 2 R for monoatomic gas, and delta T is obviously Ty minus Tx. Okay, and we can also say that for isobaric process Vx upon Tx is equal to Vy upon Ty. Okay, and Vx is the volume at point X. So Vx is 125 and this is Tx, and Vy is 250 and this is Ty. So Ty is equal to twice of Tx. Okay, and Q will be equal to 5 by 2 Nr, and Ty minus Tx is this Tx. And now we know that the process Wx is adiabatic process, and the gamma for this gas is obviously 1 plus 2 by 3. So gamma is 5 by 3. So for adiabatic gas we can say that T1 V1 की पार गामा minus 1 is equal to T2 V2 की पार गामा minus 1. T1 is equal to TW, and VW is 64 and gamma minus 1 is 2 by 3, and this is Tx and gamma minus 1, this is 125 and gamma minus 1 is again equal to 2 by 3. So TW into this is 4, cube root of 4 is, cube root of 64 is 4, and the square of 4 is 16, and this is Tx into 25. So Tx is equal to 16 by 25 TW. So you can substitute the value of Tx here. So it is 5 by 2 Nr Tx, and Tx is 16 by 25 TW. So Q will be equal to, this is 8 and this is nRTW into 8 by 5. nRTW is 1 joule and 8 by 5 is 1.6. So the correct answer will be 1.6 joules. Now we move on the next question. In this question you can see that there is a geostationary satellite which is orbiting around the Earth above the equator, and the distance of that satellite from the center of the Earth is r1. And there is another satellite which is orbiting around the Earth in equatorial plane, but the direction of revolution of the second satellite is in the opposite direction to the geostationary satellite. And the distance of the second satellite from the center of the Earth is r2, and r1 is equal to 1.21 of r2. So we have to find out the time period of the second satellite as measured from the frame of reference of first satellite. So let us first of all see that we know that T1 square will be proportional to R1 cube, and T2 square will be proportional to R2 cube, and hence T1 by T2 will be proportional to R1 by R2 to the power 3 by 2, and it is given that R1 by R2 is 1.21. So T1 by T2 will be 1.21 to the power 3 by 2, and T1 by T2 will be equal to 1.1 to the power 3, and T1 by T2 will be equal to 1.33. Okay, and now we have to find out the time period of the second satellite with respect to the first one, and omega of the relative rate of change of angle of second satellite from the first satellite will be omega 1 plus omega 2. This is not relative angular velocity, okay? So this is the rate of change of angle of second satellite with respect to the first one. So this is omega 2 plus omega 1, and this is 2 pi by t, and this is 2 pi is common, 1 by t1 plus 1 by t2. So 1 by t will be equal to 1 by t1 is common, 1 plus t1 by t2, and t1 by t2 is 1.33. So 1 by t will be equal to 1 by t1 into 2.33. So t will be equal to t1 upon 2.33. So the value of p, and t1 is obviously 24 hours, so this is 24 upon 2.33. So value of t is 2.33. This is the correct answer. Now we move on the next question. In this question you can see that there is a thermally isolated container of length L, and it is subdivided into two compartments of length L by 2 and L by 2 by a movable conducting piston of area A. The left and the right sides of the compartment are filled with the gases of number of moles, which is 3 by 2 in the left compartment, and number of moles are 1 in the right compartment. Both gases are ideal gas, and in the left compartment piston is attached by a spring whose spring constant is K and the natural length is 2L by 5, and when the system is in thermodynamical equilibrium. Now thermodynamical equilibrium means the mechanical and thermal equilibrium both are established, and in thermal equilibrium temperature will be same, and in mechanical equilibrium piston will not move, net force on the piston will be 0, and this is L by 2 and this is L by 2. So we have to find out the pressure in the right compartment in this equilibrium condition. So first of all, let us see that, let's suppose pressure in the right compartment is P1 and in the left one is P2. So P1 is N RT by V, N is 1, and this is RT by V, and P2 is 3 by 2 RT by V. Okay, and obviously V is same and temperature will be same because there is thermal equilibrium between the gases, and the difference of the pressure, obviously dP, is RT by 2V, and that would be balanced by Kx of spring force. So Kx by A is equal to pressure difference. Now X is the extension in the spring, and it would be L by 2 minus 2L by 5, and X will be equal to 0.1. So we can say that RT by 2V will be equal to 0.1 Kx by A. So RT by V will be equal to 0.2 into Kx by A. So the value of alpha is 0.2. So this is 0.2. Now we move on the next question. In this question, you can see that there is a Young's double slit experiment arrangement in which there is a combination of two glass wedges A and B. These are glass wedges A and B, and their refractive index is 1.7 and 1.5 respectively. They are placed in front of the slits as shown, and the base of this prism is T is equal to 12 micrometer. The distance between the slit arrangement and the screens is D, which is 2 meter, and this length L is 1 mm and this D is 2 mm. So we have to find out the shift in central maxima with respect to O. So first of all, let us draw the scenario. Let us draw any one wedge, and this is the one wedge. Let us see that the total length of this wedge is D plus 2L, and this base is T. This is X, and let's suppose this is Y, where this is slit S1 and this is slit S2. So by equating this tan theta, we can find out the value of X and Y. This theta, tan theta, will be T upon this total length, which is D plus 2L. Okay, and the value of tan theta in terms of X will be X by L. This is X by L. And the value of tan theta in terms of Y will be Y upon this distance. This is D plus L. So X is equal to TL by D plus 2L, and Y is equal to T into D plus L by D plus 2L. Okay. If we will substitute the values of X and Y from this, see, T is 12 micrometer, length L is 1 mm and D is 2 mm. So if we substitute, the value of X will come out as 3 micrometer and value of Y will come out as 9 micrometers. Okay, now we see that this slit S1, the light would travel a distance of X in this prism, and it would travel a distance of Y in this prism. And similarly, the light coming out from S2 will travel a distance of Y in this prism and will travel a distance of X in the other prism. So if we find out, we know that the path difference delta X due to the distance traveled in the transparent medium is mu minus 1 into T. Okay, and the mu of first one is 1.5, so it is 0.5 into X plus the mu in second one is 1.7, so it would be 1.7 minus 1, which is 0.7 into Y, and delta X into delta X part difference in the second one. This will be 0.5 into Y and plus 0.7 into X. So total delta X will be equal to difference of these two, So delta x1 minus delta x2, and it would be equal to 0.2 y minus x, and y minus x is equal to 6 micrometers. So you can see it is 0.2 into 6 micrometers. Now we know that the shift in the fringe pattern is given by delta x capital D by small d. So 0.2 into 6 into capital D is 2 and the small d is 2 millimeter. This is 10 to the power minus 6 and this is 10 to the power minus 3. So del will be equal to 1.2 mm. So the correct answer will be 1.2 mm. Now we move on the next question. In this question you can see that there is a projectile of mass 200 gram that is launched in a viscous medium at an angle of 60 degree with the horizontal. Now this launching speed is 270 meters per second, and this projectile experiences a viscous drag force which is F is equal to minus CV vector. This negative sign shows that this drag force is always in just opposite direction of the instantaneous velocity. The drag coefficient C is equal to 0.1 and the projectile hits a vertical wall after 2 seconds. If E is equal to 2.7, then we have to find out the horizontal distance of the wall from the point of projection. So we can see that obviously there is a situation in this. This is the projectile, this is its initial velocity, and this angle is 60 degree. So ux is equal to u cos 60, and u is 270, cos 60 is 1 by 2. So it is 135. Okay, and at any instant of time its velocity is tangential and its force, this viscous force, is in the opposite direction. So if, let us see that this angle is theta, this angle is theta, so f x, or we can say that vx is equal to v cos theta, and fx is equal to f cos theta, where f is cv, because we are just concerned with the magnitude now, so it is cv cos theta. So we can say that fx is equal to cvx, because v cos theta is vx, and the value of c can be substituted later on. So fx will be equal to minus mvx dvx by dt, because velocity is decreasing due to this drag force. So dvx by vx integration is equal to minus c dt by m, integrating both the sides. The limit of v will be from 0 to vx and limit of time will be from 0 to t. So it will be v ln, in fact it would be from ux to vx, because initial velocity is not 0. So it would be ln vx by ux is equal to minus c by m into t. So vx is equal to minus, in fact it would be ux into e to the power minus ct by m. This is vx. Now we have to find out the distance of the wall from the projection point in the horizontal direction. So we can write down vx as dx by dt, and it is equal to ux into e to the power minus ct by m. Okay, so dx will be equal to ux e to the power minus ct by m into dt, integrating, and the limit of the x will be from 0 to x, and limit of time will be from 0 to t. So x will be equal to ux divided by c into m with a negative sign, and e to the power minus ct by m, and the limit will be from 0 to t. So x will be equal to minus ux m by c, and by substituting the limits it would be from e to the power minus ct by m minus 1, and x will be equal to mux by c into 1 minus e to the power minus ct by m. Okay, so this is the scenario. Now the value of ux is 135, the value of m is 0.2 and value of c is 0.1. So x will be equal to 135 into 0.2 by 0.1 into 1 minus e to the power, time is 2 seconds. So if you will substitute these values, it would be e to the power minus 1. And e is 2.7 and 1 by e is, this you have studied already in RC circuits. 1 by e is 0.37 and 1 minus 1 by e is 0.63. So the value of x will be approximately 170 meters. So the correct answer will be 170 meters. Now we move on the next question. इस क्वेश्चन में बच्चों आप देखिए कि एक ऑडियो ट्रांसमीटर है T और एक रिसीवर है R. ये वर्टिकली एक दीवार से लटकाए हुए हैं और दो स्ट्रिंग है जिसकी लेंथ इक्वल है 8 मीटर. ये इनके हिंज पॉइंट्स हैं और इनके हिंज पॉइंट्स में भी कुछ डिस्टेंस है. इनको हमने दोनों तरफ थीटा नॉट एंगल पे पुल किया, जहाँ पे थीटा नॉट की वैल्यू कॉस इनवर्स 0.9 है और नेचुरल फ्रीक्वेंसी जो है ट्रांसमीटर की वो है 660 हर्ट्स और जो स्पीड ऑफ साउंड है वो है 330 मीटर्स पर सेकेंड. ठीक है ना. और हमें बताना है कि जो रिसीवर है उसे मैक्सिमम वेरिएशन कितना सुनाई देगा. अब देखिए ऑब्वियसली जब ये ऐसे जा रहे होंगे तो इनकी जो स्पीड है वो मैक्स होगी और ये दोनों एक दूसरे की तरफ अप्रोच कर रहे होंगे, तो जो फ्रीक्वेंसी सुनाई देगी वो मैक्सिमम होगी. तो मैं उसे एफ मैक्स बोलता हूँ और एफ मैक्स होगा 330 प्लस वी, जो कि मैंने वी मैक्स को माना है, अपॉन 330 माइनस वी इंटू एफ. और जब ये दूर जा रहे होंगे, जस्ट अपोजिट जा रहे होंगे पीछे इसी वेलोसिटी से, तो ये जो होगा एफ मिनिमम होगा और ये होगा 330 माइनस वी अपॉन 330 प्लस वी इंटू एफ. ठीक है. तो अगर आप इन दोनों का वेरिएशन निकालना चाहते हैं तो एफ डेल्टा एफ होगा एफ मैक्स माइनस एफ मिनिमम. तो ये होगा कॉमन यहाँ से आएगा एफ और अंदर बचेगा 330 प्लस वी, 330 प्लस वी अपॉन 330 माइनस वी माइनस 330 माइनस वी अपॉन 330 प्लस वी, ये होगा. और इसका जो एलसीएम आएगा वो आएगा 330 का होल स्क्वायर माइनस वी स्क्वायर और ऊपर आएगा आप देखिए 4 इंटू 330 इंटू वी इंटू एफ, यह आ जाएगा वेरिएशन. और अगर v की वैल्यू देखें तो v होगा √2gh, जहाँ h होगा ये हाइट और यह हाइट होगी l इंटू 1 माइनस कॉस थीटा नॉट. तो h की वैल्यू होगी v की वैल्यू हो जाएगी √2 इंटू 10 इंटू h की वैल्यू 8 इंटू 1 माइनस 0.9. तो आप ये देखिए कि v हो जाएगा 4. तो जो डेल्टा एफ की वैल्यू आएगी वो आएगी 4 इंटू 330 इंटू 4 इंटू 660 डिवाइडेड बाय, देखिए इसको आप नेग्लेक्ट कर सकते हैं 330 के स्क्वायर के सामने, और हम इस नेग्लेक्शन का भी एक रेंज बना देंगे आंसर की. तो ये यहाँ पर आप ये देखिए 2 आ रहा है, तो डेल्टा एफ जो आ रहा है वो 32 आ रहा है. अब क्योंकि अगर आप इसे नेग्लेक्ट ना करते तो इसमें से डिनोमिनेटर जो है वो थोड़ा छोटा हो जाता, तो रेंज थोड़ी बढ़ जाती. पर अप्रॉक्सीमेटली जेईई एडवांस भी 32 को करेक्ट आंसर कंसीडर कर रहा है. तो बच्चों ये था, थोड़ा लेट हो गया सॉल्यूशंस अपलोड करने में क्योंकि रेगुलर क्लासेस का भी शेड्यूल रहता है मेरा. तो मैं कोशिश पूरी यही करता हूँ कि हमेशा आपके लिए टाइम टू टाइम और रेगुलरली कुछ कॉन्सेप्ट्स न्यू लेके आता रहूँ. और मैं अभी अपनी प्लेलिस्ट को कंप्लीट करने में लग रहा हूँ और मैं हिंदी में भी सारे वीडियोस को अपलोड करने वाला हूँ एज सून एज पॉसिबल। थैंक यू।